Hi friends, let's extend our discussion. We are working on bit arrays, and here we looked in how to check whether the bit is 1 or 0, and how to check or how to set a bit 0 or 1. Here the and or gates are very much useful, and then we also seen how each bit can be just toggled using XOR operation and so on. Now extending our discussion onto a large bit array. So when the bit array is very huge, it is impractical to use it as a single array, and this can be, instead of having one array, it can be modified into or reshaped into a matrix. The sole reason for doing this is the available memory is having some limited word size. The standard word size is byte. A byte means 8 bits. Okay, now let's think that we have a very long bit array, and this bit array, if we want to put it onto our memory, maybe RAM or ROM or EEPROM or whatever type of memory you think of, yeah, it's developed such that it's having words, and each word having a size as per the developed. Here, let's assume that our memory is having a word size of 1 byte. 1 byte means 8 bits. So we have 8 columns, 0 through 7. And then, depending on the size of the memory, multiple words are allowed to be stored into this. So the index for those are given by 0, 1, 2, 3, and so on. So if you look at this carefully, then the 0th bit is available at this position. So we have 0th bit here, bit number 1 here, bit number 2 here, 3, 4, 5, 6, 7, and then 8 comes here. 9, 10 goes up to 15, 16 comes here, goes up to 23, 24 comes here, goes up to 31, 32 comes here, and so on. So we are now trying to solve the problem of how to turn on 34th bit. So if you look at 34th bit, so we find that this is our 32nd bit, 33rd bit. So this is our 34th bit. So we are working on this particular bit, which is our 34th bit. Now the question is, how do you identify this? So one way, as we did, you just keep counting 0, 1, 2, 3, 4 and all that. Yeah, that's definitely not a practical way of working on it. So we need to find out any alternative way for that. So the easiest way is try to find out in which word it is. So it is 0, 1, 2, 3, 4th word. So the word index for our number 34, the word index for 34 is 4, because that's a word index 4 here. Done. Now how about column index? Column index is 2. So how do we arrive to this? So the word index is 4. So anything, any relation between 34 making a connection to 4 and 34 making a connection to 2. So looking at this arrangement, we can see that 0, 1, 2, 3, 4 index it is. That means it is there in the fifth row. Row number 5. So row number 5 means after 4 rows completing, it's in the third position. So after 4 rows it is coming. So if you just count the full rows before this one, how do you count that? So counting that will be 34 by 8, because each row contains 8. So 34 by 8 is 4 point something. So this something is not important to us. What is important is how many complete rows are there before this particular row which contains our 34th bit. Yeah, that is 4. So how do I separate 4 from this whole thing? Of course, use a floor. So we get a 4. So done. So we got a fourth one. So if you call this A, then you can say A of 4 will be what? 1, 1, 1, 1, 0, 0, 1, 1. Right. So what are we interested in? We are interested in making 34th bit high. So that is this bit, we want to make it high. So to make this bit high, what is required? And on the other same time, we need to make sure that other bits are not disturbed. So we make 0, 0, 0, 0, 1, 0, 0, and then OR it. Then this is 1, this is 1, this will become 1, this remains 0, this remains 1, this remains 1, this remains 1, this remains 1. So with this, what happens is this particular bit has changed to 1. So that's the logic behind doing this. So how do you do that? Yes, first thing, take out A of 4. So how did you get 4? 4 is 34 by 8 floor. Then to this, what you need to do is or what? 0, 0, 0, 0, 0, 1, 0, 0. Yeah, how do I get this? How do I relate this with a 2? Yes, of course, as we discussed earlier. So 1, 2, 3, 4, 5, 6, 7 zeros, and the least bit, if you keep it 1, and this shift to the left by 2 bits, then we get this. So what is this? So that is 1, you left shift by 2. What is left shift? By 2. How do you get 2? Yeah, 2, how do you get? So this is 32. After 32, 2 more are remaining. So I can call this as a 34 remainder after dividing by 8. So finally, I can say that it is take 34 by 8 floor and then OR with something which is 1, which is left shifted by how much? 34 percentage 8. So 34 percentage 8 is 2. So left shift 1 by 2. Then we get this. This you OR with this. That's what we are doing here. And that's what we get. So at this position, you just OR this whole word with 1 at the position number 2. Then we get only this particular thing changed to 1. So in general, if you are talking about nth bit, then take the bit array, then do n by 8, then or, then 1 left shift by n percentage 8. So that's as simple as that. Now this is working for 8-bit word size. So today we have 32-bit word size, 64-bit word size memories available. If that is the case, then it can be any word size. So if I consider that our memory is now 32-bit, then one word will be from 0 to 31, then second word will start from 32, goes up to 63, and so on. The whole metric structure changes. Nothing to worry much. The same thing is to be used, only difference is 34 by 32 or 1 34 32. So same thing, instead of 8 write 32, instead of so now you can work for any bit array of any word size. So that's how the thing can be done. So if you are setting it, yes, we know we need to define this mask and or it with the word. If you want to reset it, just take the knot of this and with it. So if you want to reset this, then you have a 1 here, then 1 1 1 1 0 1 1 1 if it was there, then you and with 1 1 1 1 1 0 1 1, then this position 0 will make this to be 0, and all other places 1 will retain all things as it is if you go for an AND. AND is with the inversion of this, use AND, then it will be for reset action. Now this we have done is for this process we have done is set action, this process is reset action, and if you want just to keep toggling, then use this window and then go for XOR, that works for toggle operation. So many things are possible. Now the question is why are we interested in all this bit array operations, so much of efforts we have put in. So what is it going to help us in? So that's what we see in our next session. So keep waiting. Thank you.